Hey, in this series we're going to be covering inverse trig integrals. So all these integrals are going to lead us to get inverse trig. So I'm talking about arctan, arcsine, or even arcsecant. Those are the main three we're going to focus on. Everything else are just negative signs of these three that I just mentioned. Alright, so this is different from partial fractions in that with these you don't have many intense calculations. It's more of craftiness in this one. You're trying to be crafty to spot which one you have in front of you, so boom, you can use your formula. So I'm going to write down the three formulas I just mentioned. Alright, so these are the three formulas we're going to be using throughout this entire video. So the first one says the integral of du over a squared plus u squared equals 1 over a arctan of u over a plus c. Now my a's and u's kind of look alike, but I'm going to blame the marker. It's the marker causing that. Now this one says for arcsine, the integral of du over the square root of a squared minus u squared equals arcsine u over a plus c. Now this final one for arcsecant says that the integral of du over u times square root of u squared minus a squared equals 1 over a arcsine u over a plus c. Now these are something you should memorize. And with memorizing, I do different tricks to memorize. First of all, they all have u over a as the argument of the inverse trig. That's the first thing to remember. Also, for arctan and arcsine, they both have the a squared coming first. So you can always say a should come before u. Think about the alphabet. So it's a squared plus u squared is tangent, square root of a squared minus u squared is arcsine, and then arcsecant is just all messed up. It's all switched. There's an extra u in the front. So just do different things like this to memorize them. And then you can write them on your page. Like in a test, just write them on the top of your page. That way, during the problem, you don't have to think about it. Just write them and then you can do it. Or if you're doing your homework, just write it at the top of the page. Alright, so let's get started. For number one, we're given the integral of 1 over the square root of 25 minus x squared. And we have to relate this one to one of these over here. So it's a square root with a minus, so that's going to be arcsine. So the way it works is the dx is the same as the du up top, so that's fine. I don't have to worry about that. So the way it works is one of these is a, one of them is u squared. So my a squared is 25. That means a is 5. So now let me rewrite this so it looks more like that. So it's going to be the integral of dx over square root of 5 squared, because that's what the form looks like, and then x squared, right? So now this is an exact match, because you got the 5, the a being squared, and you got the u being squared. So it's going to be arcsine of u over a. So this one is just going to be arcsine of u, which is going to be my x, and then a is going to be 5 plus c. So for this one, I just have to look at it and say, hey, which one does it match? It matches this one here. So that's my answer. So for number 2, I'm just going to give you some basic ones to get you warmed up so that you can just easily spot them early. So this is number 2. In the denominator, we have a sum. So it most closely resembles number 1. So it's probably going to be arctan. So what I'm going to do is try and find out what my a is and what my u is. A is supposed to be a number being squared. U is supposed to be the function that's being squared. So I'm going to write it like this. So 36 would be my a squared. So my a has to be 6 squared. Now my 9x squared is going to be my u because that's the function. But I don't want u squared, I just want u. So that's going to be 3x. And then you got to put the square. Good. So now this very closely matches this one. So we have it in the correct format, and we can see that it's arctan. There's only one thing that's off. Right here, this is my u. Right here is my u. But at the top I should have du. The derivative of 3x is not just dx, it's 3dx. So there should be a 3 up here. Then I have it. And it's perfectly fine to just put a 3 there because it's just a number. But if I put a 3 there, I've got to divide by 3 somewhere. So I'm just going to put 1/3 at the front. Alright, so now it matches exactly, and I can just write down what it is. So it has to be 1/3. My 1/3 has to stay in the front because that's just the coefficient of the entire integral. But the integral is equal to 1 over a, so it's going to be 1 over 6, times arctan of u over a. My u is 3x. My a is going to be 6. Now, if had this been indefinite, I would put a plus c, but it's actually definite. So I need to evaluate this from 0 to 2. So what I'm going to do is I'm going to simplify this and I'm going to plug in. So this is going to be 1 over 18 arctan of x over 2. Value from 0 to 2. Because this reduces just to be 1/2, so the same as x over 2. So now I can just plug in to evaluate the endpoints. So it's going to be 1/18 of arctan of 2 over 2 is 1, so it's going to be arctan of 1 minus 1/18 arctan of 0. Alright, so now I need to evaluate these. And arctan of 1, that's just going to be pi over 4. That's going to be 1/18 times pi over 4. Now arctan of 0 happens at 0 radians. So this is just going to be 1/18 times 0. So it's 1/18 times 0. So that's gone. So my answer is pi over 72. Pi over 72. Alright. So now you get pi over 72. So that's the area of this function between 0 and 2. So most of the examples I'll be doing will be indefinite integrals, but I just wanted to show you how to evaluate it. You just follow the same method. Once you get your final answer, just plug them in. Alright, let's do number 3, another basic one. Alright, so then this is the next one, and it's a fraction again, so it's going to be 5 plus 4t squared is my denominator. So I've got to see which one does it most closely resemble, and most closely resembles arctan. Only thing is I'm using t instead of my usual x, or my usual u. But that's not a difference. I'm just doing this example to show you that the variables can be different. Okay, so first I need to write this in a better form. I want to see my a squared and I want to see my u squared, so I can just easily recognize them. So this is the integral of dt over 5 is going to have to be my a, because that's the number. But this isn't a perfect square, but that's no problem. I'll just put square root of 5. So square root of 5 squared plus 2t squared. Because 2t squared is equal to 4t. So now I have my a, and I have my u. A, and this is my u. Alright, so let me do a quick check. Is the derivative of my u at the top, because it's supposed to be d at the top? It's not, because there should be a 2 up here. That's no problem. I'll just put a 2 here, do my same 1/2 at the front, and I can keep going. So now this matches exactly. So this turns out to be 1 over a. No, I need to put the 1/2 in the front. So it's 1/2 times 1 over a. A is square root of 5. So it's going to be 1/2 square root of 5 times arctan of u over a. My u is 2t. My a is square root of 5. And I need to put a plus c because it's an indefinite integral. Okay, so that's how you do that one. So you just gotta look at the fraction you're given and see which one it most closely resembles. And because for this one, we have a squared at the bottom. The squared is really the big giveaway, because once you have a squared and you just have a constant at the top, you're very limited to what you can do, because substitution won't work and a lot of the methods will not work. So we're stuck with inverse trig. So for this one, we just located our a and our u. Our a has to be the number, or u has to be the function. And then once you get it in that format, you can say, hey, is the derivative of my u at the top? And it is, because the derivative of x is a dx. And we can solve it. We end up with arc sine for this one, just following the pattern. For this one now, we have a plus, and it's a regular fraction. So we wrote it out so it resembles the pattern as much as possible. Then we end up with this 1 over 18 arctan. And since this was a definite integral, we have to plug in our endpoint to solve it. And then we have 1 over 18 arctan of 1 minus 1 over 18 arctan of 0. Arctan of 1 is pi over 4. And then we just get pi over 72 when we multiply it. And then for this one, we're given this. We don't see a perfect square, but that's okay. We're going to take the square root of 5 and just use that as our a, and then we just say, hey, this is something being squared. 2t is what? 2t squared is 4t squared. This can be my u, and I'm almost there. The only problem is my derivative of my u should be at the top, and derivative of 2t is 2 dt. So I need to put the 2 in there, and that's fine. I just pull the 1/2 to the front so it cancels out, and then I have it. So this is my answer. Now for this one, you could rationalize it by multiplying by square root of 5 over square root of 5, but there's no need to do it here. This is an acceptable answer. Alright, so I'm going to write down the examples you're going to be doing, and it would be great if you could try them on your own to see if you can just get the hang of them, and just work with me as I do them, or you can just watch the video then try them at the end, but it's very important that you do them on your own. Alright, so let's go. Okay, so these are the examples I'll be covering. We already did 1, 2, and 3. This is number 4, so try them on your own. We've got the integral of dx over x times the square root of 16x squared minus 4. We've got this one, and this one says integral of t over t squared times square root of t to the 4th minus 49 dt, and this one over here looks interesting. Okay, so for number 4, we've got to see which one does this most closely resemble, and we have a minus sign right here, and a square root, and an x in the front, so it sort of looks like this one. So there's a good chance it's going to be arcsecant. So let's see what the formula says. The formula says you should have your u outside, you should have your u squared, and then you should have minus a squared, and then du should be on the top. So most logically, this would be my u, would be in here, and then this would be where my a is. So I'm going to say this is my u squared, and this is my a squared. And then that means this has to be my u. Okay, so now let me try and rewrite this. So I'm going to get dx, leave that as x. Now this is u squared, I just want u. So this says that u has to be 4x minus 2. So this is supposed to be my u, and this is supposed to be my u as well. This is supposed to be my a. And I need to have a squared right here. Okay, so it almost looks like this. The only problem is these two u's don't agree. They don't agree. And up here it doesn't agree either, because it says my du should be on the top, and the derivative of 4x is not just dx, it should be 4dx. So I'm going to fix this problem first. So I need to have a 4 up here to make it really the derivative of this. So now that's fixed, but to put a 4 there I need to divide by 1/4, like what we did before, so I can divide by 1/4. But instead of putting the 1/4 out here, I should just put it inside the integral, because then it's going to fix my problem here. Let me show you what I mean. If I put the 4 here, now everything agrees. This is u, this is u, and this is going to be my du, and this is my a. So you can see now it perfectly matches my formula for arcsecant. Now I can just read this out. It's going to be 1 over a, so it's going to be 1 over 2 arcsecant of u over a, and u is 4x, a is 2 plus c because it's indefinite, and I can simplify this just to be 2x. So it's 1/2 arcsecant of 2x plus c. My answer for number 4. Alright, so number 5. So this is a punchline. Get it? A guy walks into the bar and he says dx over x times square root of 16x squared minus 4. You know what I said? I said 1/2 arcsecant 2x plus c. Alright, let's go to number 5.